Okay, so now that we have reviewed arithmetic and geometric sequences and series, and then talked about what to do if it is a sequence or a series and it's non-arithmetic or geometric pattern, now we just want to talk about some application problems with sequences and series. So obviously, first thing you should do is read the problem. Then the next thing you decide if it is arithmetic or geometric, and then also if it's a sequence or a series situation. And if it's arithmetic or geometric, then there's formulas available, and then the sequence or series would let you know which formulas to use, and then you try and answer the question. So number one says an advertising agency begins a telemarketing campaign by making 50 phone calls on the first day. Each day after, the agency will make 10 more calls than were made the day before. So if you write the first 5 terms, that should help you determine whether it's arithmetic or geometric if you're unsure. The first day, they're going to make 50 phone calls. The second day, they're going to make 10 more than they did the first day, so that would be 60. And then the next day is 10 more than the day before. So you can just continue that pattern. And so when you write out the first 5 terms, it should make it sort of obvious that this is in fact arithmetic with a common difference of 10, where the first term is 50. So we're finding a formula that contains a sub n. That's also been asked is find the nth term, find the general rule, find the pattern. So we are going to use the sequence formula to do that. So since it's arithmetic, we'll use a sub n equals a sub 1 plus n minus 1 times d. And we will replace a sub 1 with the first term and d with the common difference. And then if you just clean that up, distribute and combine like terms, you should have 10n plus 40. So that would be your a sub n. That's the general rule. It is the pattern. So at this point then, n would represent what day we were on, and you could substitute whatever day for n and quickly figure out how many calls were made that day. So then part C says find the total number of phone calls made during the first 50 days. So total number would indicate that we're interested in the series. So you can either continue to use the generic formulas, or you can try and incorporate the more specific nth term formula. The arithmetic series formula is S sub n equals n over 2 times a sub 1 plus a sub n. So if we're trying to find the total for the first 50 days, then we know n is 50. We were told that 50 calls were made on the first day, but we need to know how many calls were made on the 50th day. If we're trying to add up the first 50 days of calls, then we need to know how many a sub n were made on the 50th day. And so here's where this will come in handy. It'll be fastest to just substitute 50 in right here. And that will tell us that on the 50th day, there were 540 calls made. I don't know why I put that in parentheses. And so that would go over here. And then we can calculate that sum of that series. So over the first 50 days, there were a total of 14,750 calls made. All right, looking at number 2, a botanist measured the height of a plant once a month and charted its growth. Suppose that the initial height is recorded as 4 inches and the height increases 10% per month for a year. So again, find the first 5 terms. So it said that the initial height is 4 inches. So then at the beginning of the second month, and that's kind of important because it started out, the initial height is 4 inches, and then it increases 10% per month. So at the end of this month or at the beginning of this month, it has increased 10%. Okay, so this is the beginning of month 2. Now, in terms of arithmetic or geometric, if it's 10%, that's going to tell us it's geometric. But if I just use an R value of 10% and I multiply 4 by 10%, then it's only going to give me the increase in height. It's not going to give me the new height, considering the original height and the increase. So for that reason, you can't use just 10% for R, but you need to use 110% or 1.10. Okay, 10% will just give me the increase in height. I need the increase plus the original, and that's why it's 110% or 1.10. So if you multiply 4 by 1.10 at the beginning of the second month, it's 4.4 inches. And then you take 4.4, multiply it by 1.1, and you get 4.84. Beginning of the fourth month, 5.324, and the beginning of the fifth month is 5.8564. All right, so find a formula A sub n for the height. So again, we've determined it's geometric because we're multiplying by 110% each time. A sub n, meaning find the general rule or the pattern. So we can use the sequence formula for that, where we replace A sub 1 and R. So that would be considered my A sub n formula. And then the total height of the plant after 9 months. So this, it says total, and that might think it's a series, but I don't want to add up all the heights. Like, that's not going to do me any good. This is the height when they first took the measurement. This is the height at the beginning of the second month. I don't want to add those two together because 8.4 doesn't represent anything. It represents initial height plus the height of it is at the next month. So that number doesn't really satisfy any question I would have. So even though it says total, because we want to just know what the height is after the 9th month, and after is important, then that would still be a sequence question. But because it says after 9 months, I would say we use n equals 10. So we'll know what it is at the beginning of the 10th month, since this was beginning of the second month. And every one of these is the beginning of that month. So A sub 9 would be the beginning of the 9th month, and I want to know what it is after 9 months. So I would do A sub 10. A sub 1 is 4, the R value 1.1, and then I would just put 10 in for n. And at the beginning of the 10th month, which would be after 9 months, it should be 9.432 inches. Pretty slow growing plant. All right, next question. A formation of a marching band has 7 marchers in the front row, 10 in the second row, 13 in the third row, and so on, for a total of 10 rows. What kind of sequence does this pattern create? Well, if you were to write out these terms, it's 7, and then 10, and then 13, etc. So that would allow you to be very clear that it is arithmetic. If you say it's arithmetic, you should also be able to say what the common difference is, and that would be 3 in this case. So then find the general term of the sequence to model the number of marchers. So if it's arithmetic and we want the general term, that's your A sub n formula. So we're going to do the A sub n. We're going to replace A sub 1 with the first term, and we're going to replace D with the common difference. We are going to distribute and combine like terms, and we end up with the general term, or the pattern, is A sub n equals 3n plus 4. Then C says how many marchers are in the band. So in total in the band. So there's 10 rows, and we know how many marchers are in each row. I don't want to know about the number of marchers in an individual row. I want to know all together. So that would indicate that it's a series, and the arithmetic series formula would be used. So it said there were 10 rows, so I need to add all those 10 rows together. There were 7 in the first row, but if I want to find the sum of the 10 rows, then I'm going to need to know how many marchers are in the 10th row. So that's where I can use this and replace n with 10 and get that there are 34 marchers in the 10th row to replace right here. And so there ends up that there are 205 marchers altogether. Okay, number 4. An object dropped from a certain height will have fallen vertically 12 feet after the first second, 44 feet after the second, 76 feet after the third, and so on. So let's write that out. It says A sub 1 is 12 feet, A sub 2 is 44 feet, A sub 3 is 76 feet. So I don't know if any of you are in physics, thought that there was this whole gravity thing that would affect, like it wouldn't have a constant falling, but it's only falling from 12 feet high. And I guess you would have to factor in sort of like the speed and the weight of the object, but just saying. All right, so it seems like this is arithmetic because the pattern appears to be that we're increasing the distance falling by 32 each time. So then it says, how many feet will the object fall during the 9th second? So just during the 9th second would indicate that it is just a sequence problem. Instead of A sub n, since I know specifically it's the 9th second, the A sub 1 was 12, n is 9, the common difference was 32, and so I would get 268 feet. Then it says, what is the total number of feet the object has fallen at the end of 9 seconds? So the total number here would mean that we're going to use the series. So we want S sub 9, 9 over 2. The first was 12, but we're going to need to know, we now use this A sub 9 that we found here. So this was the number of feet fallen in the 9th second, and that's what we need right here since we're adding up 9 terms, and the total height fallen was 1,260 feet. All right, a running back agreed to a contract that pays him a guaranteed salary of $1.8 million plus a bonus incentive of $1,000 for scoring 1 touchdown, $1,800 for scoring 2 touchdowns, $3,240 for 3 touchdowns, and so on, up to including 12 touchdowns. Wow, this is really similar to what they paid me as a teacher. I wish. All right, so the first touchdown, $1,000 bonus. Second touchdown, $1,800 bonus. Third, $3,240. And that goes all the way up to n equals 12. So it looks like the increase is $800 is the first between the first touchdown and the second one. And it's definitely not $800 from the second to the third, so it can't be arithmetic. So if you do 3,240 divided by 1,800, and then 1,800 divided by 1,000, in both instances you will get 1.8, so it must be geometric, and R is 1.8. Okay, so we're supposed to represent this bonus incentive as a sequence. It's up to 12 touchdowns, so it would be A sub n, and then A sub 1 is 1,000, and R is, oops, I'm using the arithmetic formula. That's not a good idea when it's geometric. Times R 1.8 and then n minus 1. So that would be how you would represent the bonus incentive as a sequence, a geometric sequence specifically. But because it's only up to 12 touchdowns, you would want to specify that n is between 1 and 12. After 12, I don't know what happens, but I guess you renegotiate your contract for the next year. All right, how much money will he be paid if he scores 9 touchdowns? So if he scores 9 touchdowns, then that will still be a sequence question because he's not going to get paid the 1,000 for 1 and then 1,800 for 2. They're going to recalculate. This is how much bonus you get at the end of the season based on your total touchdowns. So I'm just trying to figure out how much that bonus is because he scored 9 touchdowns. All right, and you come out with $110,199.61. But how much money will he be paid? That's how much money he'll be paid in bonus money because of the 9 touchdowns. But he's also, remember, earning that $1.8 million. And so it's a total of $1,910,199.61. Tough life. All right, last question. An automobile worth $18,000 depreciates in value each year such that its value at the end of the year is 5/6 of its value at the beginning of the year. Beginning of the next year, I would say. Represent the depreciation as a sequence. Okay, so if you kind of think through, it's only worth $18,000 to begin with. And then next year it is 5/6 of that. So in order to figure out what it was worth at the next year, you would have to multiply by 5/6. So if you take 18,000 times 5/6, then it's worth 15,000. Beginning of the second year, multiply by 5/6 again, then it would be 12,500, etc. So it must be geometric, where R is 5/6. So if we represent that as a sequence, A sub n equals A sub 1 times R to the n minus 1. How much is the automobile worth after 5 years? That's still a sequence question because I'm not combining years. I just want to know just in the 5th year what's its value. So that means I want to find A sub 5. So n must be 5. And after 5 years, it is worth $7,233.80. Assuming the automobile is maintained properly, after how many years will it be approximately 6,000? Okay, so this is actually, I do a little recall here. So we actually know this value over here, and we know the beginning value, and we knew what R is. We want to figure out what year gets closest to it being worth $6,000. So we have to solve this exponential equation. So first you would divide both sides by 18,000. 6,000 divided by 18,000 would give you 1/3. And then this goes back to our logarithms and exponential functions unit. It's an exponential equation where it's impossible to rewrite the bases so that they'll match. So we have to use logarithms to solve it. You can use common log or natural log. What you do to one side, you do to the other. So either log or natural log. Then any exponents need to move out front. That's expanding. Then you would distribute over here. And we're starting to move things away from n, so we would add the log of 5/6 to both sides. And then divide by the log of 5/6. And then you would put that in the calculator, because if I asked you after how many years the car is going to be worth 6,000 and that was your answer, I would look at you like you had 2 heads. So you would want to put that in the calculator, and then you could answer in a reasonable way about 7.026 years. Okay, that's it for this one. Exit ticket, next class.